Hello, students. Welcome to week 2 of MSBA 305. I know week 1 is a lot to wrap your head around. I posted the welcome video. Most of you have not watched it, but please take a look at it because I'm going over the syllabus, explaining the assignments, and also go over the lecture for week 1. Going forward, I will record a short video every week, and I go over the main learning that we do in the week, and I go over the assignments that I do in the respective week. So we're in week 2. Last week we had a good discussion. We got a good start into the material, but now we're really getting into it. So give me a second and I will pull up the presentation for this week, which you also have online. And in the meantime, if you have any questions, you can always email me or post a question in the question and answer forum if you think that other people might be interested in the answer as well. One question that came up in the auto grader for the quiz in week 1, there's a problem, and we will have this problem a couple of times throughout the semester. The auto grader is not very smart. For those of you who are technical, it does just a string match. So when there's an answer, it looks for an exact string match. And so if you have something out of sequence, if there are multiple components to the answer and it's not in the exact sequence that the autograder expects, it will mark it wrong. So I will have to manually correct that. Don't be alarmed when you see that you got it wrong, although the content is right. If you have not exactly the same sequence or you add on a comma or something like that, then the autograder marks it as wrong, but I will override this when I go over all the quizzes on Sunday morning. Okay, so this week is chapter 9, which is also about dimensional modeling. Dimensional modeling last week was a chapter 8 and chapter 9. And this week, the first assignment is also due, which is the entity relationship model. And then you read part of chapter 6. So again, we talked about this last week. What is a dimensional model, which is also called a star schema? And you see here a fact table for online sales, which, by the way, is similar to the use case that we have, the gym fitness use case. There's also sales of membership cards and merchandise items in the gym club. And you see here the different components, for example, sales quantity, sales amount, return quantity, return amount, etc., etc. So when you organize this in a dimensional model, you have the key components, for example, the data key, the store key, data key, the product key, the customer key, promotion key, current key, all these keys, you put them in the fact table, and then you think about the different dimensions. For example, product key, what dimensions could this be? This could be different types of products that you want to analyze, or different types of promotions, different types of currencies, different types of stores. So these are then the different dimensions. Here, just as an overview, this is the difference between an entity relationship model here on the top and a dimensional model. In the entity relationship model, you build all the entities, and again, these entities have to follow a very strict modeling technique because this is for operational systems. This has to follow Boyce-Codd normal form and be ACID compliant, which means in the resulting table there can be no repetitions. Everything has to be unique because if you want to roll back one element of the transaction, you have to know and pinpoint exactly which one you want to delete, and that's why you sometimes have to create intermediary entities and keys that are composed of multiple primary keys, etc., etc. We don't have to worry about this in a dimensional model. In a dimensional model, we have one or two fact tables in the center. That's why it's oftentimes looks like a star schema. This is actually in this, you can see why it looks like a star schema. Here, this one is a little bit more complex. So let's dive into a practical example. When you look at a table like this table of top salespeople, what are the dimensions and what are the facts? So in this example, you see here the names of salespeople, and then you see how much revenue each salesperson generated. So if you're going back to this model here, the salespeople would be in the name of the salesperson is a dimension of the fact salesperson. Okay, salesperson would be a fact, and the dimensions would be the names of the salespeople. And then what's also a fact is the revenue per salesperson. These are facts that we get from our revenue tracking system, and we track it by the number of the salesperson. So we can then create a report and say how much revenue did each salesperson generate. And then below here, you see an example for dashboard. So the top is an example for a chart. We have basically one fact, which is sales per dimension salesperson represented in this chart. In the dashboard, we have multiple elements of this. So this is already an example for a dashboard, right? So you see here the dimensions. This is region, for example. Here you see Australia, Canada, France, Germany, United States. These are dimensions because you can organize the revenue by region. Another dimension would be time. You see here, this is over multiple years. You can organize the data by multiple years, so that's another dimension. And the fact is always the sales revenue, right? So the facts can be represented in multiple ways. Here, the fact, the revenue is in a table. This is, again, our table of salespeople and how much revenue they generated. In this case, these are resellers, not direct salespeople. So here are the resellers, and there's different types of resellers. So these are all dimensions in which we organize the data. And the factual data that would be in the fact table is revenue. And then you have different dimensions like time, region, individual person, individual reseller, etc., etc. So I hope that gives you an understanding of what facts are. In this case, the revenue that comes from the operational system and what the dimensions are. And the dashboard is a great example that the dimensions then will be represented in multiple ways. And in this dashboard, we have the reseller business type, the different dimensions, and then we show the facts, the revenue per business type. Another way to look at this is with OLAP cubes, and the discussion this week is about OLAP cubes. So the fact measures go into each segment of this cube. So each cube has a fact in it, which is revenue, but the cube is multidimensional. So it has a date dimension, a geography dimension, and a product dimension. So what does that mean? It means, let's say if we have product 1, 2, 3, 4, 5, and 6, and we have multiple geographies, then each cell would contain the exact revenue of a particular product in a particular geography. So how many printers did I sell in Germany at in 2011? So let's say this would be 2011, 2012, 2013. And you know exactly how many printers I sold in Germany in 2011, 2012, 2013, because each cell here has exactly that data, and the address of the cell is determined by the dimensions. Okay. OLAP cubes are both a concept and a technology, but when you look into Excel, you will see that Excel actually has the ability to connect to OLAP data sources and import the data into Excel. And Excel will then represent it obviously in Excel format. It gets a little bit complicated when you have more dimensions. You have 5 or 6 dimensions, which is possible, but it's very hard to visualize that many dimensions. But it's definitely possible that you have more dimensions than represented and can be visually represented in an OLAP cube. So the architecture, and I told you this last week already, is always the same concept. You have the system of record, you have the system of integration where you do the data integration. So we have our source systems that generate the data, we integrate the data, we cleanse the data, we normalize the data, and then we put it in our systems of analytics. By the way, one interesting aspect here is that OLAP cubes are represented both on the system of analytics and in the business intelligence layers. And you saw some examples, the dashboards, reports, spreadsheets, etc. This is the user interface, the front end, basically. So the assignments this week is you do the mapping of the gym fitness database, part 1. This is a typing mistake. I will correct this when I post the presentation. It should be Saturday before midnight, not Sunday before midnight. So Saturday before midnight. So you do the mapping of the description that you have. You create a relational model and entity relationship model that you map into relational schema, and then you transfer the relational schema into a dimensional model. The discussion is about OLAP. There's a reading quiz as every week, and I will delete the team project because, as I said, we don't have a team project in this class. So when I go over the screen share, wait a second, to do a new share. Okay, so I just wanted to show you, I posted a lot of material an example entity relationship model, entity relationship diagram to the two-dimensional star schema that explains how to do this. There's another article, entity relationship to star schema. And then I posted instructions on how to create a Windows instance in AWS. So again, you have two options for next week when we start with the dashboard. When we do the dashboard, you can either use Microsoft Power BI, which is the default. And if you have a Windows laptop, you can just download it, install it. It's free, and you're ready to go. And you don't have to worry about this. If you are using a Mac, which in my experience a lot of students do, you have 2 or 3 options. Option number 1 is you use MicroStrategy. They have a free tool similar to Power BI, that MicroStrategy desktop, that you can download and utilize natively on the Mac. If you want to use Power BI, you can either install a simulator on the Mac, Parallels or Bootcamp, and use your Mac computer to run Windows. For those of you who use more Windows applications, that might be an option. And then again, the third option is you create a AWS instance. It's free. There's instructions on how to do that. And you can then install Power BI in that AWS instance and run it like that. Of course, that's a lot more work. So if you want the way of least resistance on a Mac, use MicroStrategy. Okay, I will make sure I update all the links, and I update the presentation because we don't do a team project this semester. And that's it for this week. So good luck with the entity relationship diagram, relational model, dimensional model. There's a lot of material that you can read and study. This is a graduate class, so I want you to do some research and then apply it and submit the dimensional schema. You can use ERD Plus for all 3. For the entity relationship diagram, it automatically maps it into relational schema once based on the entity relationship diagram. But then you have to manually create a dimensional model based on the relational schema. Okay. So with that, you have all the tools that you need. Think about your project. This week, there's no assignment due yet, but think about which data set you want to analyze, and if you have a data set in mind or a research project in mind, great. If not, start your research and see, so you're not forced to pick the first data set you find when the assignment is due in the week when it's due. Okay, with that, good luck and fun this week, and I'll talk to you next week. Bye-bye.